third method, and the most useful one to find the resultant of concurrent forces, is to use the rectangular components of the forces. Two or more forces may be replaced by their resultant. By reversing the process, any force F can be replaced by any number of forces whose resultant is F. Replacement forces are called components of the force F. As shown in the figure, Fx and Fy are called the rectangular components, and they are usually determined in the horizontal and vertical direction. Rectangular components of a force vector may be found mathematically by trigonometric functions. In this equation, we have cosine of theta equals OC divided by OB equals Fx divided by F. Then solving for Fx, we get Fx equals F times cosine of theta. Sine theta equals CB divided by OB equals Fy divided by F. Then solving for Fy, we get Fy equals F times sine theta. The final expression of the horizontal component of a force Fx is the force times cosine the angle it has with the horizontal axis. And the expression of the vertical component of a force Fy is the force times sine the angle it has with the horizontal axis. Let's look at example 1. Two forces are shown here, P and Q. Using the expressions we developed earlier, we will be able to find the horizontal and vertical components of these forces. Show the x and y component of the force P. So Px will be P cosine theta equals 14 times cosine of 55 degrees equals 8.03 newtons. Py will be P sine theta equals 14 times sine of 55 degrees equals 11.47 newtons. To show the x and y component of the force Q, Qx will be negative Q cosine theta equals negative 12.5 times cosine of 65 degrees equals negative 5.28 newtons. Qy will be negative Q sine theta equals negative 12.5 times sine of 65 degrees equals negative 11.33 newtons.